Good morning or good afternoon, depending on when do you watch this recording. My presentation will touch the topic how this DCC, Digital Calibration Certificate, help the process industry in their digital transformation journey. The content itself is here. So what are we going to discuss today? First of all, the challenge that the process industry is having today, how their processes work today, and how DCC will fit this existing process, and does it require any changes? And then where to start the digitalization, and then potential obstacles. Yeah, my name is Sami Koskinen, and I work for BMX. I've been doing this now 25 years, and I've been mostly helping process industry to implement the better way what comes to the calibration. Typically what I do is analyze the existing calibration processes and then identify potential steps that could be enhanced. And DCC is a very interesting project for BMX and of course personally to me. We all know this pyramid, and we all understand the importance of the calibration to be able to guarantee the reverse traceability all the way up to the true value. However, today in my presentation I will be focusing the industrial challenges, and they are here at the bottom of the pyramid, where they manage their working standards and then their planned process instruments. And being in a business 25 years, what I've learned is that these two bottom levels require a lot of work, to calibrate them all on a yearly basis. The ratio between the calibration tools and then the instruments is roughly 1,000 certificates for the calibration tools and 100,000 certificates for these process instruments. And this represents average value for the process industry. And I'm talking about now the one company that performs the calibration, especially like pharmaceutical, they are very calibration intensive because of the regulation and that they need to guarantee the patient safety. So this is the ratio, 1,000 calibration certificates for the calibration tools, 100,000 calibration certificates for these process instruments per year. And this leads the process industry then, of course, to look for help. And what they've done is that they are here as a customer. That's the process industry. And then they have a calibration service providers that provide the calibration services for them to be able to perform all those hundreds of thousands calibrations. And the calibration service provider is playing a key role in their processes. And how it works today. First of all, the customer itself, they raise a service request, and then it requires a technical preparation. Once technical preparation is done, then they will pass the service request to their calibration service provider, whether it's on a paper or a PDF or email. However, it's pretty much a manual process here. And then the service provider will check in the service request into their own systems. Then it goes to the next step to a technical preparation on a calibration service provider side. And here they need to make sure that they have all the required tools available. They will reserve the resources for the calibration work itself, make sure that they have appropriate reference standards available, and so on and so on. What happens next? That they travel back to the customer factory, into the factory on site. They have the tools with them, they have all the procedures, how to calibrate, all the specifications, all the protocols with them, all the reference standards with them, and then they execute the calibration. They put it on a paper, and then they come back to the office. Then they sign off the work, put it in their systems, and most likely they will archive the paperwork. And then it moves to a next level, which is then that the service provider is able to close this service request and will check it out and invoice. In this step, they will ship the calibration certificates and of course then invoice to the customer. Then the customer will receive the certificate. They do their own technical approval, review the certificates, and then what happens is that they will, in worst case, they will manually type in all the results into their systems and then scan and archive the papers. And then it moves to next step, and service can be then closed, and then of course rescheduled, and then payment, and then the loop starts all over again. So where are the bottlenecks? Here they are. Every single step requires a lot of work, and there's a paper that moves on. And what are the issues here? What are the real issues? I have listed now the 4 main challenges that the process industry is facing today when they use outside calibration service providers. It's very labor intensive. It's very time consuming. There's a lot of data integrity issues. And then finally, the data that they have on a paper in a binders, it's not available for the data analysis. Well, then the question is, are we able to change this process? And the answer is, of course, yes. And I see that the DCC have a key role to enhancing this cumbersome, labor-intensive, time-consuming process. And I think this is the short-term target for the DCC for the process industry. So they will replace all the paperwork and then send the digital calibration request. And then that will be digitally then handled by the calibration service provider. And then everything needs to be digitalized here also. Otherwise, there still will be data integrity issues. And then finally, when the service is closed, then they will deliver the digital calibration certificate to the customer. And then technical approval, of course, is required still. And then data analysis, they are able to do the data analysis and then close the service. And I believe this is the short-term target. And if we go back, we can see that what is the difference. There are many steps that can be replaced with this digitalized process. And at the end, DCC is delivered. However, I think that we can do even better, and you know what we are demonstrating then and creating some demonstrations with the pharmaceutical industry today is pretty much the process that you see here today on this slide. However, I think that we can do better, and I think the long-term opportunity here is this type of a process where everything can be automated because we have everything in a digital format. So we can drop off a lot of those manual steps still between. So basically there will be just 2 lines, digital calibration request and then the digital calibration certificate back to the customer. Well, the journey will not be without pumps. And what we already identified during our research, that at least, you know, here we have identified a couple of challenges. The DCC today, it doesn't hold the digital calibration request part. So that has to be done, you know, by something, you know, by some other means or ways. That is one identified challenge today. So service provider typically needs the calibration procedures, you know, the range, approval limits, when to adjust, and so on and so on. So customer needs to provide the procedures to the calibration service provider. The other challenge that we have identified is then who and where this original DCC is created. Is it done on the field here by the technician, or is it done when the record is created in the calibration service provider systems, or is it created here when the work is actually closed and then DCC is sent? So where and who will create the DCC? Okay, so where should you start? And I believe that everything starts from the bottom where you actually calibrate your instruments. So you need to evaluate all your tools that you use today. So start, you know, take a look at your tools and start with the tools that support your digitalization strategy. Leave out the paper and, you know, take a look at all the processes that you have and think that where can you leave out the paper and all the tools that doesn't provide you the digital record. And then favor those tools that helps you to digitalize the calibration itself on the field already, whether it's a documenting calibrators or laptop or tablets, but try to focus on those tools that helps you to digitalize the calibration on the field. And this is something that you need to do together with your calibration service provider. And try to automate as much as possible. And what I'm meaning by the automation is that how can you automatically capture the calibration results on a field? And here I have one example. How do you utilize the documenting calibrator, smart documenting calibrator on the field to create the calibration record automatically. Let's take a look at it.
Hello, this is Roy Tomalina with BMX. And during this short video, I'll show you how to calibrate a temperature loop using a BMX MC6 and a BMX FB150 dry block. We'll be doing this as an automatic calibration, calibrating this temperature element and this temperature transmitter. Continuing doing an automatic calibration, we need to make the connections. So let's break this down. We'll start off with our temperature element that we're plugging into our temperature source. That connects to our temperature transmitter. The transmitter converts this temperature into a milliamp output. The calibrator then measures that milliamp output, and at the same time we can provide a 24-volt loop power back to power up the transmitter. The dry block itself tells us what temperature that it's at. If we need, we can have a more accurate sensor. In this case, we put in a high accuracy temperature reference probe, and we've got that plugged into the front of the dry block. Now, if your temperature block model doesn't include this port, you can connect this reference probe right to your MC6 here. Now, to connect the MC6 to the FB150 dry block, we take a USB cable. The dry block takes a serial cable, so in between we simply have an adapter to adapt USB to serial. We have our connections made. It's time to take the next step. Documenting calibrator. You see the list of what you have due for the day, or maybe what's due for your shift. In this case, I have one. It's position TT124. Just before this, I brought it over using CMX, our calibration software, so everything was loaded up with all the critical details. As a technician, I simply touch on the instrument. This gives me a rundown of what I'm doing. It tells me what the instrument name is, it tells me what the function is, it tells me what the input and output parameters are, and it even tells me where to plug in. Maybe I'm a new technician and I haven't used this a lot. So this tells me for my input, I need to connect my USB. You can see it in green right here. USB cable connecting me over here to my temperature source. And the output of the transmitter is right here. And that tells me to hook up right here. So this will measure the milliamps and provide loop power. We have a 3-up test strategy. And our input is 0 to 100 C. And the output is 4 to 20 milliamps. So now it's time to get started. I'm going to hit the check mark. And then all we do is hit the start button. It's that easy. We've reached our first test point. You can see a countdown happening right now. We had a 10-second delay set up. So once it reaches that test point, it will count down to whatever delay we've set. So it's just finished counting down our delay. It grabbed the test point. You see that represented as a green circle. Our next test point is right here. So on the bottom right, it'll show you where you're going, and that says we are heading to 50 degrees C, and we're expecting 12 milliamps out. While this is increasing in temperature, let me explain what's going on with the screen here. On the top left, you have the input. It tells us that we're hooked up to a temperature source. It tells us we're hooked up to an FB150R. The R means that we have a reference probe attachment right here in the front. And it's also in degrees C. Now the top right is the output, so that's where we're measuring milliamps. And it tells us that the supply is on. The next section down is the graph. So the graph is where are we on this calculation. So the middle line is our 0. If there's no error, our test points will be across that all the way. The blue dotted lines above and below our 0 represent our tolerance. So our test points can be within the blue lines anywhere down the graph and still pass. We're getting a live reading of error, and it takes a while as we're heating up there's a little bit of a delay from our temperature probe, and that's why we have a settling delay at the end anyway. At the bottom we have a pause button, so we could pause our calibration if we needed to for some reason. So at this point now, we just wait for it to hit 50 degrees C and grab our second test point. We've reached our second test point. Now it's counting down from 10 seconds. You can see this here. Then it will grab that test point and then start heating up to the final test point. There we can see it's a little bit above the zero. We can see the error right now. And if we look at our serial to USB adapter, we can see that it's actually communicating. One is the send or transmit and one's the receive. So now we'll hit 100 degrees C and finish our final test point. We've reached our final test point. We have our 10-second countdown before it actually captures the result. Did it pass or did it fail? So it will always tell you whether it passes or whether it fails. We get to see our error. It was 0.333% of span. 0.5% of span was our tolerance that we decided upon before we even started. So this tells us a summary of what's going on. If I hit the down arrow, we then put in who did the calibration and any calibration notes. We get a visual representation of the graph of the test we just did. Hit down one more time and we get to see all of the raw data. To save it, we just press the disk and save it as found. Hit check. Now at this point, our as found is done. If we decided that for some reason we wanted to do a trim, we could do that. We just press this upper left-hand button and start communicator. We could calibrate this as a HART transmitter. If it were a Foundation Field Bus transmitter or even a Profibus transmitter, we could do all three types. So now you know how to do an automatic calibration of a temperature loop using an MC6 calibrator and an FB150 temperature block. In this case, our next step would be to take these results and unload them into our CMX calibration software. Again, through this entire process, we've never picked up a pen, we've never picked up a piece of paper. So this is completely paperless automatic calibration with the push of one button. Now, if your temperature block doesn't happen to be green, we do support a good number of temperature blocks out there. So we'd like to thank you for watching and check out our other calibration videos.
Thank you, Roy. So there you just witnessed that one way to digitalize your calibration activity on a field. It creates automatically your calibration certificate in digital format. And of course, it doesn't end there. I mean, it's the beginning of your journey to digitalize the entire process. Then, of course, you need to evaluate your current calibration management systems and strategies. Also take a look at your maintenance management system and does it integrate to these digital systems, and how can you pass the information between. And then the next level will be that once you have everything digitalized and you have the data available in digital format, then you should share it. The sharing it will help all the others. First of all, inside your corporate, especially if you are global, you have multiple factories all around the globe. You should then share the data between the factories to learn and see that, you know, how the calibration program could be then enhanced, and how does it help you to get your processes leaner. For example, extend your calibration intervals from 6 months to 12 months, depending the trend that the system gives you, and all the other data analysis that this digitalization brings to you. And then, of course, you can create the digital twins and try to see that how this calibration data could actually help you to enhance the production itself. And this is called then the Industry 4.0 as a purely a calibration perspective. Well, I hope you now understand the challenges and potential solution that DCC could bring for the process industry. If you have any further questions, please don't hesitate to contact me. Thank you.